Tu m'entends, Valentin? C'est bon? All right. Good morning, everyone. I'm JB. I'm the secretary of Silex Labs, the non-profit organization organizing the WWX. And I'm also a web developer at Secret Media, one of the sponsors of the conference. And first, I'd like to welcome all at WWX 2016, the fifth edition of the Haxe conference made by Silex Labs. And for this fifth edition, we decided to try something new. We tried to create a free and open source organization for a free language and community that she deserves. So everything in this conference was proposed and discussed on GitHub. And a lot of you took a part of it in the process, and that was wonderful. Thank you all. We wish you'll enjoy the fruit of our conjoined effort as much as we will, because it's it's an open source, it's free, you all take part of it, so it's our conference and not just Silex Labs. So thank you. But you all know that after an issue is open on GitHub, after we talk about it, you need someone to do the actual thing. And so I'd like to address a special thanks to all the people who did that. Thank you, Uri. Where are you? Here. he did a real work to rethink the WWX design. You all see the new logo. You all see the wonderful, responsive website. So thank you. I'd like to thank Valentine, who's here, who maintains the website and harass the speaker for infos, pictures, and bio, and so on. Thank you to Clemos and Franco, who can't be here today, but took a great part in the organization. They made rehearsal. They help everyone to get the most out of their talk. So thank you. And of course, all of the Silex Labs members, the team, especially the 3 employees who made a wonderful job at project management, helping volunteers, and all the community management. We can't organize a thing like that without people working on it full time. So thank you all. They're all here. So thank you. All right. Finally, thank you all who contributed on the crowdfunding on Ulule, because you made this happen by funding us. So thank you all. Thank you very much. Speaking of funding, this year we've got a completely new set of sponsors, as you see, and we're glad to welcome them at WWX. So you see Docker Holding, who sent us their best tech team, I think. You've got Secret Media, best tech too. We've got Keymetrics and Gandhi, who help us with the t-shirt. And of course, we still have our key sponsor, like the Haxe Foundation, and Mozilla, who let us use the wonderful conference room. Without transition, our host, Nicolas, is here, and he'd like to give you a few words about Mozilla. So please welcome Nicolas, our host.
Hi everyone, I'm Nicholas. I work at Mozilla. I'm a software engineer here, and I just wanted to say that I've had a really great time last year at the same event, so I'm really excited about this weekend. I don't want to divert too much from the actual stuff happening here, so I just want to say that if you guys have any questions about Mozilla, the open web, contributing, whatever, I'm going to be hanging out in the office with you guys for the entire weekend, so just come talk to me if you're interested in chatting about Mozilla things related to, I don't know, graphics programming and this kind of stuff. So yeah, thanks for coming, everyone. I really didn't do much in the way of organizing this event outside of providing the office space. So a big thanks to the actual organizers, and have a great time. I hope it's been a good conference for you guys. Thanks.
Thank you, Nicolas. Now, a quick recap about the organization behind WWX, Silex Labs. So for those who don't know it yet, we are a non-profit organization. And we've got 3 employees I talked earlier. You've got Antonin right there in black shirt. You've got Simon, which is with Twitter around there. And Laura, that maybe some of you see yesterday. So they're helping out for everything we do here. And they're back up with a dozen of volunteers, which try to help us in any way they can. But to do what? For those who didn't saw my talk from last year, go watch it. And while we're waiting for you to watch it, I'm just giving you the key point of the organization. So we're doing workshop to help people get a hold on digital technologies. And our volunteers are professional IT people, and they go on to school or youth center and local mission and to train people who need it the most. And for this purpose, we create an online website editor, which called Silex. It allows you to make your own website without technical skills. And by the way, there is a crowdfunding on the way for Silex, for the software. And if you think helping people who need it is important, please go fund it. We'll very appreciate it. And to wrap it up, this is going to be a great WWX because everyone take part of it. And even if we didn't have all the funds we'd like, I'm sure we made the most of it. And so this is going to be great. And we're counting on you to spread out some Haxe love on the social network like Twitter. Be sure to follow the WWX 2016 hashtag. And so tweet it, retweet it, share it, and do everything you can so everyone heard about it. So thank you all, and enjoy the weekend and the WWX. Thank you.
All right, I'll just wait for the video to switch over. Awesome. Well, thanks everyone for coming. It's great to be here. I missed last year in this venue, so this is a huge upgrade from 2 years ago, which was the last time I was here. So another big thanks to Silex Labs and Alex and everyone else putting this event together. This is pretty nice. So, anyways, the second thing I'm super excited about is I get to introduce Haxe and Lua together and talk a little bit about the new target. And so the premise of this talk is this image, which was true as of a couple days ago. Everyone's familiar with this phrase and this image. And my contribution was this. So we have a new member of the family. Haxe can now target Lua, and I want to talk a little bit about Lua and why I think it's a compelling target and why I think you guys should get interested in it, and talk a little bit about what you can do with it. So there's various programming language popularity contests out there, so take these with a grain of salt, but this is basically a chart of a huge portion of the most popular ones, measured on two axes. One is the number of GitHub projects, and one is the number of Stack Overflow tags. And the text is a little bit small, so I'm just going to go ahead and highlight this. There's Lua, which is surprising, because that means the farther you are in the upper right, that means, by both those metrics, you're doing very well. So it's in the 75th percentile or so of all languages, which was surprising to me earlier on when I looked at this. And so you can get the full spread of like what Haxe, where Haxe falls, which is more or less in the middle of the pack, versus everything else that it targets. And it's clear that we've kind of got the high end of that covered. A lot of the first class targets, such as that are used, almost everywhere, such as C and Java, JavaScript, you name it. They're all clustered in the upper right. But then Lua is actually moving that direction. So I think it's definitely a target to watch. And so why is that? Why are people getting interested in Lua? And one is it's actually very fast as an interpreted script language. And then on top of that, there is an environment called, a platform called Lua JIT, which is a very fast JITting compiler. So once again, these is going to be a little bit small, but Lua shows up in here. And these sort of canned benchmarks. This one is looking at solving a Sudoku puzzle. This other one is looking at matrix multiplication, pattern matching, counting unique strings in a dictionary. Lua basically will hold its own against virtually anything, any language, static, compiled or not. And Lua JIT will, it's now showing up. Like if you want to say that your target's fast, you have to compare it to Lua JIT and say how that stacks up against that. The other really compelling thing about Lua is that it's the base quote unquote vanilla install for Lua is tiny. It's about 100K. So it's used a lot in certain cases where you want to put an embedded scripting environment on an embedded device. Where the memory constraints might be severe. So it's very popular for that. So this is, once again, you can strip down PHP and JavaScript and Python. People do that all the time. But you're also, you're breaking with sort of the default path of those targets. And if you just sort of keep to the normal install for all those targets, they're many, many orders of magnitude bigger than what you get with Lua. So Lua's designed to stay small. And because of that, like I said, it's typically bolted on for a lot of different applications, and in particular, game scripting is very popular with Lua. So World of Warcraft has a really nice script interface to a good chunk of its API, and people have gone completely nuts with that. This is a Lua editor written in Lua as a plugin for World of Warcraft. There's books on this. In addition to World of Warcraft, it's the first class scripting engine for CryEngine, which is a high-end 3D gaming platform. And then one of my personal favorites, Baldur's Gate, uses that as well for all the NPC dialogue and branching interactions there. On top of that, it's also becoming very popular for web development. So if anyone uses Nginx as a framework, it has a Lua interface now. It's one of the fastest things you can use to serve web pages. It also Redis has a Lua in its API. There's various web frameworks that wrap Lua, OpenResty and Sailor. And then it's also big time in the game community. So there's various frameworks that are available. I'm actually not personally familiar with some of these, but maybe some of you guys are in the gaming community. But yeah, it pops up in a lot of different places, including scientific computing. There's an editor that I'm interested in called NeoVim that uses it. It's used as a scripting layer for a lot of Adobe products, and it's used for protein folding in other scientific domains. And on top of that, I'm not the first person to come along and say, hey, Lua is interesting, we should, I want to figure this out. From the point of view of the Haxe community, other people have dabbled with Lua and tried to integrate Lua. So there was first and foremost, I was excited, there was an unfinished Lua target around 2008 that was geared towards Haxe 2 that never quite reached the finish line. Then there's various wrappers. There was a special JavaScript compiler that could output Lua, and then there is different types of native bindings that people have put together that interface with primarily CPP code. And then there was an interesting article where Nicholas was comparing Lua to Nico and kind of investigating some of the design trade-offs involved there. So Lua kind of shows up a lot in the way that in the Haxe community, just in trying to integrate it somehow. It seems like it was close. Lua is very similar to JavaScript, and that's something that we have a very strong target for. Does a lot of nice things, and when you look, you kind of squint your eyes at the code. There's some parts of it that look kind of JavaScripty, and you're like, oh, this. Lua has meta tables, JavaScript has prototypes, those kind of seem the same. There's obviously, the first class functions as closures, there's this sort of catch-all hash that can function as an array or an object. And it seems like, that's a strong lead, that maybe this isn't so hard. The problem is that Lua is, as I've said before, is extremely simple. So they've stripped out a lot of things that most people would take for granted. And this was kind of my impression of my first week there. I was like, where are the integers? Where's binary operations? Like, where is all this stuff that I can't imagine, coding without? So there's an immediate challenge where you almost have to bootstrap basic functionality with Lua in order to sort of reach what I would consider sort of a standard coding experience where you can expect to use regular expressions, you can expect system libraries, networking, etc. Lua is very minimalistic and it's not going to offer that out of the box. At least in this case, there's an asterisk there. They are starting to add integers finally in 5.3. So I'll talk a little bit more about the version differences. So I just wanted to give a really simple snippet and just show how a standard hello world main would translate into Lua. And you can see like functionally the layout is very similar. Obviously we kind of need to build up objects and then attach functions to them and then call those functions. And for the most part, this is for very basic hello world applications, this is pretty straightforward. And then just to give you more example of like what you're likely to see in the output and how that translates to what you actually entered in with Haxe code, any kind of bit operations get converted into special method calls that Lua can provide. So if you're doing any kind of bitwise calculations, you'll start to see those pop up in your output. And standard things like X++, Lua doesn't have that, so those have to get mapped into expressions and generated as part of the output. And this is just showing how kind of complicated it can get, where we've since everything in Haxe is an expression, and in Lua expressions are much more constrained. You have to in some cases expand out the X++ and ++X into a series of temporary variable allocations and then save those and then apply them all in one expression at the end. The other challenge was for anonymous objects, Lua has a single type of table variable that basically covers covers use cases from arrays to hashes. But one of the big tricks there is that if you try to assign a null valued field, it'll just forget about it. So anything that comes across as null, you can't detect that it was ever there. So what I'm showing here is just there's a special wrapper function that I have to include that basically lets you save those references and detect that, oh, I did have a reference to this field of this name. So in the generated output, you will see a bunch of these helper methods that sort of that are sort of a preamble to make sure that Lua objects work the way that you'd expect them to in the other targets that Haxe does. And moving on, and then whenever you create an anonymous object, it will save the values. So here we've got X, Y, and Z. And it will save also the presence of X, Y, and Z in a separate table. So that just sort of makes those two things explicit. You've got the presence of that field, and then you've got the value of that field, because Lua sometimes will get forgetful, and you want to make sure that it always keeps that reference. This I'm going to gloss over very quickly. We need that strong anonymous class to do things like reflection. Like if we want to say, give me all the fields, we need to know if they're null or not. And then in object-oriented programming, we need to know which fields are part of which class. So with this new and improved anonymous object type that we bootstrap in Haxe, we can basically build the prototype or the class for all of the instance methods that we want. And as a quick overview, just with metatables, I mentioned that they're very similar to prototypes. This is sort of the magic that lets this happen. Metatables are basically, you can attach a metatable to a table, and then in certain cases, like if you say, give me this field, give me the field foo on this table, if it's missing, and it has a metatable, then it will invoke one of these special methods attached that's a part of this metatable. So in this case, this is how I handle everything from inheritance to missing fields to all of the different reflection checks I need. It's all metatable magic. So once again, when you see these in the output, that's what's going on. This is basically to make the tables behave like proper anonymous objects or proper OOP constructs. And to give one more example, so that with object-oriented programming, we're building on the anonymous table behaviors, and in this case, we're declaring a constructor. We're calling a helper function to create the new object, and then we have the prototype, which is basically like a payload of all the methods for that class. That gets attached as the index metatable, and then we call the super method, which does basically everything in the new method, which sets the fields, and then returns that object that it created. So it's almost like a sandwich I put together. There's all the variable declarations, there's the methods, and that all gets returned as part of the constructor. And it basically lets you using reflection, you can get all the fields, you can get all the methods. And maintain, and it lets the runtime know how that object is structured. And then for inheritance here, I'm introducing this super method, which basically does the field modifications that I talked about. And then if you have a class that inherits another class, basically we're just adding another metatable to that prototype chain. So it's that other class that you're inheriting. And then that super method, which does all the field changes, you basically call both supers. So this basically lets me treat Lua as having object-oriented programming and have all of the fields and variables that they're distinguishable in the runtime for reflection purposes. It's a little dry, but just kind of wanted to take a moment to mention how that works, because there's a lot of people that I think don't like to do OOP and Lua, and in this way you can, at least the compiler's handling that for you. So it takes care of a lot of the pain. One of the other things going on is there are a lot of Lua libraries that you want to use inside your Haxe generated code, and there's some metadata available, so you basically can mark up extern classes and whatnot with these to let you access Haxe-generated code from other Lua code that you might be using. And if you've used the JavaScript targets, either through like a browser JavaScript or Node, you'll be familiar with these. They're basically expose binds a method or a class to the global namespace, so you can write up a really nicely structured Haxe class ontology, and then you can choose which ones you want to export out and then use those externally. And then, yeah, so self-call, there's some other features in there that let you just sort of work with externs and exported Haxe code in a comfortable way. And yeah. So the other thing I wanted to offer, like in addition to the Lua target, I started this about a year ago, and I didn't know much of anything about the Haxe compiler and or Lua and or OCaml. So this hidden in the Git repo now is virtually, obviously every commit I've ever made, and I tried to do a decent job of describing my thought process of like, what do I do first? What's the first file I need to alter? What do I need to, how do I convince the compiler that it has a new target and that it should, generate code in this fashion? So it's kind of unfiltered. I don't think I use any curse words, but it's me kind of just talking aloud to my terminal. So and most of the commits have maybe not quite this long. They're not paragraph level, but pretty good information. And that first command there, that git log reverse grep Lua, will basically catch all of the Lua references, and those are basically me. So it starts from the beginning. So we have a functioning target, but I do have to warn there's some kinks to sort out. There's still some things that I kind of wish I could have polished up a little bit better. So one of them is Lua has this restriction where you can't declare more than 200 local variables. And first of all, I would say if you're doing that on purpose, you'd probably want to think about maybe refactoring a little bit. But in Haxe, we have abstracts, we have inlining, and we have all these ways where variables are created kind of automatically. So it's something to be aware of, and it's something that you don't want to. Whenever you try to use code designed for other targets, is something you want to make sure that maybe you turn off some of the inlining, try to prevent some of this extra variable creation. The sys API is also incomplete right now. I'm working kind of case by case with some folks that are trying to get the basic file system stuff working, and it is. The problem is that Lua once again doesn't provide kind of a standardized interface to that, so it's literally like going in and finding externs that I can use or libraries that I can extern to get like consistent file and process activity across all these different platforms. And then, as I mentioned before, it has a special notion of nil, which is it doesn't really distinguish like a missing value from an empty value. So whenever you try to do things like concatenate nil, it has problems, whereas most of the other Haxe targets will act gracefully and just concatenate the string null. That's not there's also one of the other things that Lua does is it will have multi-return methods, so you can return multiple variables from a single method call. And this is part of some ongoing discussion, and we're trying to figure out a good way of allowing the Haxe syntax to describe that and then return it and let you operate on those, let you extern a method that does that and then operate on those values in a sensible way. And then, of course, this is sort of my first pass at all of this. So I'm working on optimizing the generated Lua output a little bit, making it as readable as possible, but then also as compact as possible, so that you can fit this on smaller devices in terms of file size. Right now, there's really only 3 bugs. However, not very many people have used it yet, and it's sort of like the extreme early adopters right now. And so the other thing I wanted to talk about was just some special aspects of the Lua target that I don't think I'll ever be able to fix, and you just sort of want to understand and avoid. This 200 local variable case is not something I'm going to, like, even when I have a workaround in mind for it, I'm working on that. But in general, trying to use more than 200 local variables means that they can't really be local anymore, and I'll need to find some mechanism to do that. And when I do that, that means all the variables after that, after 200, are going to be slow, some kind of a slower access. So you want to, in general, avoid creating a lot of temporary variables. And that basically boils down to, be sensible about, refactoring and make sure you don't have too many local declarations, and then avoid excessive inlining of code that creates temporary variables. The other thing that's a little, that Lua is not particularly good at is, it's not that it's not good at it, that's not fair. It just doesn't have it doesn't have this notion of an instance method versus a static method. So there's some helper methods that basically constantly have to wrap and unwrap methods whenever you assign them to different fields, so that they can bind to the instance and behave the way the rest of the targets do. But whenever you do that, you're adding more overhead because I have to wrap everything. So these things in general, they're not a great idea. So they're relatively rare in the Haxe code base, but you don't want to assign instances back and forth between, or you don't want to assign methods back and forth between instances. The other thing is, this is like basic Lua protocol. You want to avoid using Lua arg, which is accessing the argument for a method. It's basically a table of all the arguments, and avoid using the Haxe extern rest when you can, because these two methods, when translated to Lua code, they'll disable a lot of JIT optimizations. So whenever you make methods, if you want to make them fast in LuaJIT, be explicit about the arguments, enumerate them all, and then use those. Most people do in Haxe. That's pretty much the norm anyways. And then there's a lot of ways to bootstrap Lua code. As I mentioned, you can basically insert raw Lua code as helper methods for your Haxe code. And when you do that, typical warning, don't overwrite an important field or a variable name. So try to use unique identifiers there. There's not many safeguards, but I do that a lot in the standard library. So yeah, I mean, taking a step back, I'm pretty happy that it's that besides a few warts, it's feature complete outside of some missing sys methods. And my takeaway here was that OCaml, I think is people are a little bit hesitant to check it out because it is very different. But really, it's not so bad. You pick it up, and Simon and company have done a good job of kind of reorganizing the code and structuring it in a better way, and helping you understand where the which files are responsible. Basically, everything that's prefixed with gen is a target. So if you look up gen Lua, that's most of the code. That's basically all the code I wrote, with the exception of some standard library modifications. And then in general about Lua, I feel like it's made very few mistakes. It's got some quirks, but it's a very solid little language. The counterpoint to that is that it also has very few batteries included. It doesn't try to do very much. It kind of leaves a lot to other library authors. And one of the problems that's come out of that is that the Lua ecosystem is getting a little fragmented right now, because there's breaking changes between 5.2 and 5.3, and then LuaJIT is actually a completely independent project, and it's more like Lua 5.2.5. It's got features of both. So right now I'm focusing on 5.2 and LuaJIT. Those are the sort of the fastest and the versions in widest use. And I'm trying to handle some of the other issues coming out of Lua 5.3. The other big lesson I learned was had a son in the last year and a half or so, which was really exciting for me. And the funny thing there was the big lesson learned was finding free time was extremely easy at first, because he slept most of the day, and I had paternity leave, and so I took out huge chunks of this project, and I had a full head of steam. And then lately, he doesn't sleep so well, so it's some of the commits and things have trickled down to next to nothing. So, you know, if anyone's thinking having a kid, you know, you got to do as much work as you can right up front. And so what you're seeing on the right here is the commit graph, basically going back all the way to when Haxe first started. And the other thing that was kind of fun was just kind of seeing my name pop up there finally with some of the other contributors. But you know, I felt like I did a lot of work, and it's this tiny little blip down here. And meanwhile, you got Simon and Nicholas up here, and they are just absolute machines. They just churn out so much stuff. So I think I still am impressed by, you know, kind of what the things that they accomplish, and even after, you know, doing a core target, there's still even another level of expertise above that. And then if I were to do it over again, I think I would start from scratch and just kind of take all, like, JavaScript seemed close enough for me, but I think there's enough little catches and hooks that if you're not really familiar with how everything comes together, you'll end up forcing a lot of round pegs into square holes when really you probably just should take a step back and do what's best for the target. That came out in my work in the sense of a lot of the things that I did was just rewriting expressions as inline strings for generated Lua code. There's a ton of debugging methods and things that help print out stuff in TypeML that I just kind of skipped or missed that would have been helpful. And the other thing I would have done is bother the other core developers more. I think I kind of just kind of learned as much as I could on my own, but they sometimes would just solve things in 5 minutes what would, you know, take me a couple days. And then, so now we're to the point where it's like, you know, the target was done, more or less, or at least available in the core Haxe Foundation repo. And this was one of the things that really made me happy. Less than 24 hours after that happened, one of the game framework developers wrote a wrapper for the whole thing and put that up. So it's kind of neat to see some people already, you know, kicking the wheels on this and trying it out in different ways. So Love is another one is a Lua framework for games, and there's already a wrapper and then a wrapper generator for that. Engine Hex is something I'm working on. I mentioned that Nginx has this Lua scripting ability. And Nginx is already fast, and the LuaJIT environment's fast. So I think this has the makings of a really great web development platform for, you know, extremely high throughput websites. And it's everything. You write your. You can't really see this here, but there's like a hello world, and then you just extern the NGX module, and you get access to everything that Nginx lets you do. The other cool thing that I started working on was getting back into Warcraft, which I never thought I'd do again. I was hoping I'd never do again. But it has its own API, and these two environments are great for me because I get to see how Lua is kind of used in the wild and how best to sort of map all of the functionality to a couple of these minor variations, and I'm trying to get better at that. So actually, how much time do I have? Let's see. Does anyone know? 12 minutes? Okay, so let's play Warcraft. So I've got my my character here. I'm too cheap to actually pay for that, but okay. So we got Mr. Haxe Lua here. We're going to enter Warcraft here. And we don't need too much sound here. But basically, I've got this little, I basically wrote a macro and then I bound it to one of these menu bar actions. So it's right here, and it just says "Hello World," which is great. I mean, not the most interesting example, but yeah, that's great. That's great. But really, we wanted to say. So I just want to show a little bit of the workflow here. So you just say, rather than "Hello World," we want to say "Hello Warcraft." You compile that, and then over here on back in World of Warcraft land, you need to reload the UI to get those new changes. And now we have Hello Warcraft, which is nice. So you get kind of a nice. It's not like completely live, but very quick iterations for doing little tweaks. And we can go one step further here. Let's see. Let's pull this up. So just wanted to expose a little bit more of the logic available. So now we're looking at. Maybe I can bump that up. Sorry about that. Now what we're doing, instead of just saying "Hello World," we want to inspect whether the character is an enemy or a friend, and then tell them, to go get bent, or tell them like "Hi," depending on the current status. So once again, we'll compile this, and once again, we'll reload. And now this guy here is an enemy. So we're going to say, "I will destroy you." So it knows we can use the API to get that information, and then change the Haxe logic appropriately. And then this guy over here is a friend, and say, "Oh, hey," we can give him a little wave, and yeah, and everything's kind of working off the API. So once that's completely populated, you'll be able to kind of browse the methods and variables and pick out whatever you want to do. And yeah, so that's about it. Come back into here. Yeah, so that's up on Haxecraft, and I'm probably, to be honest, I'm probably not going to maintain this. So if anyone else wants to lay claim to that name, feel free, and I'll give over the kind of minimal API support that I've got externed right now. So yeah, let's recap. The things I wanted to communicate was just that Lua I thought, is a pretty great target. It's small, speedy. It's great for sandboxing, gives you a lot of flexibility, and pops up in a lot of interesting places. I think a lot of the goals and sort of the way the Lua community operates, what they're interested in, it's really similar to ours. And so after this talk, I'm actually signed up to do a very similar presentation at the Lua workshop later in October here. And I think that Lua offers a couple more niches, especially with game scripting and some of the different scripting things they do. That if the Haxe community is interested in that, then that's Lua is definitely where it's at right now. So the versions, I talked a little bit about the fragmentation. I'm considering Lua 5.2 and then Lua JIT as sort of the first class, maybe the best supported versions right now. And then 5.3 works if you use the backwards compatibility flags when you do 5.3. But that's still a work in progress to have that kind of idiot proof. You can use the Haxe Lua commit messages from the repo if you're interested in just sort of how you put together a Haxe target and like what goes into it and what the basic flow is. If you do a target, you're not doing the whole thing. You're using all of the great AST translations, and there's a lot of work that happens before you actually render the output. And once again, like Simon and Nicholas have done some great work. Basically, if there's a language feature that hits every target, like those guys do that. And then as a target author, you just sort of render that AST back into the code that the target understands. So it's not starting from scratch when you're doing a target, which is it's kind of a great introduction. And then I talked about a few of the early projects and just kind of showed just through virtue of Lua being very lightweight and easy to use. A lot of them are very nice to work with. They're pleasant. World of Warcraft has its own like Lua console and debugger, and had no problem. I had no idea how it worked and literally got it working in like 15-30 minutes. And there's already some folks doing some other wrappers and projects with it, which I think are great. I think it's great. And that brings us to the end. And yeah, I'd be happy to answer any questions or hear any other comments. Sure.
I think Vim supports Lua scripting, right?
Yeah.
Maybe it makes sense to write the Haxe for Vim Haxe 10.
Yeah, that was one of my original motivations was that the Lua scripting layer for Vim, and especially NeoVim, which was one of the other projects I mentioned, I thought was a lot faster than even Python. So it was something. I know that there's another project called Tides that's out there that's basically looking into providing a project that does multi-platform IDE support. And so my roundabout rationale for this was like, I want Lua because it's fast, and then I want to contribute back to an IDE project to improve Haxe's ability to be used on editors on many different editors on many different platforms. Because right now things are a little bit uneven. Like I maintain the Vim plugin. There's Sublime Text. There's IntelliJ. But different editors let you do different things, and I think really like we should probably have one code base that helps you do all that and kind of improve improve things across the board. Great.
Is there any Haxe?
Oh.
Is there any Haxe feature or concept where you'd say that was the hardest to get right on Lua? Any specific one?
That's a good question. I think I hit so many stumbling blocks, and I think it was just I think in some cases I hit really bad ones, and then you'd figure it out in 5 minutes, and I'd be really embarrassed. And but yeah, some of the trickiest ones were 64-bit integers, because Lua doesn't have integers, and it has floats, which aren't really the same thing. So required a lot of clamping and kind of different variations of binary and bitwise ops. So that was tricky. Figuring out kind of how I wanted OOP to work and maintain all of the reflection the features that I wanted. That was tricky. And yeah, there was just a lot of problems. Like I think you get to that hello world state very quickly, and I think for me that happened in about a day or two. I could write out that simple Haxe main and generate the output, but then it's the last detail. It's that unit test suite that's just brutal, and it covers a lot of problems. So yeah, too many to name.
Yeah, so you say you use externs for various things. I say Lua externs. Does that then extern into native, or for instance, the file API, is that native underneath?
Yeah, so basically Lua is by definition a scripting layer over like vanilla C, and so C doesn't have POSIX or any of the other features of like a modern, like any kind of a modern system. So if you want to access that in Lua, you first of all have to say, well, am I targeting Windows or Linux, or what am I doing? And then you have to wrap that API. So Lua is basically externing those raw system commands, and I'm in turn externing the Lua commands. So there's a layer of abstraction there. Lua is only going to basically handle one API or another, and I've got to figure out a way to abstract that away so that I can you basically can you install the system layer for your system, and then everything will work through one consistent Haxe API, so you don't need to worry about it after that. So that's still a work in progress. Well, great. Thank you, everyone.
Okay, thank you, Justin. We're now welcoming Emmanuel for Pistahx. Yeah.
Hello, everyone. C'est VGA. So, hello everyone, and thank you for being here. I'm Emmanuel, a backend engineer at Le Kiosque, and I'm here today to speak to you about my project called Pistahx, which untitles as a type-safe, design-first Haxe web API framework. So the project is hosted on GitHub and also have a website. And you can reach me on this email or on GitHub if you need. So a little disclaimer before I start. Pistahx is still work in progress and also is an open source project, so everybody is welcome on the project if they want. Let's start with a little background about me. I started coding at the age of 15 when I got my hand on this magnificent computer, which you can use with magnetic tapes. So you insert the tape on the player and you play the tape and you wait until all the data gets on the computer, and then you can play your game. This was my first start with computing. And a small time later, my uncle offered me this nice computer, portable computer, black and white. So it was really, really nice. I was thrilled to discover all the stuff like Windows, batch scripts, games, and later on game dev. And that was it. Coding became my true passion. And after that, many, many years later, after working many years in the IT field, approaching different kind of businesses and problematics, technologies, languages, challenges, I eventually came across the Haxe language and toolkit only a few months ago. And since then, I've been addicted to this language and technology, which I find very, very cool. So nowadays, I'm working at a company called Le Kiosque, and we already use Haxe in production for various problems and challenges. For example, we use it for writing portable JavaScript libraries, which we embed in mobile apps. We also use Haxe to design data pipeline workers, which we ship in Docker containers, and we deploy them in the cloud after that. And we also use it to write some desktop tools using Electron packaging, which is part of the Node.js ecosystem, and helps you get your app, your Node.js app, to the desktop. And also for writing admin interfaces and brand new APIs for our future projects. And this is why I started the project Pistahx. So now let's dig in the project itself. First of all, I want to speak about some really common problematics people have with developing APIs, especially when they start to work on legacy APIs. Legacy APIs are often old and slow and developed with old code and development tools. And it implies heavy costs due to technology stickiness. For example, licenses to get and infrastructures. You are often stuck with this old technology and you want to go further. Often these legacy APIs don't have any documentation or specification, so it's really hard to start on. And also they have some performance issues, often related to bad caching strategies or no caching strategy at all, so this is really bad. And we also have some really common predictability, scalability, and deployability issues. So this is all really not fun. So maybe we can imagine something better for our new API projects. Now, Pistahx is an effort to solve all these issues by helping you and your development team to code, deploy, and scale type-safe, design-first Haxe web APIs. So, Pistahx, of course, the name refers to the core of the technology, which is Haxe-based. So developers can continue to write type-safe business classes and the code stays clean and safe. And for now, Pistahx projects only target the Node.js target. In the future, maybe we will open other targets, but for now, Node.js seems a good choice because the ecosystem of Node.js is really, really big and it can be deployed on almost any environment, on any stack. Pistahx you also use in the core, use Redis as an ultra-fast cache store and implements multiple layers of caching within the framework. It also implements a specification called OpenAPI, which formerly was called Swagger. Maybe some of you know it yet. Which it's a great specification for APIs. Just a little round trip on the OpenAPI initiative website, which I welcome you to discover. This is a consortium it's a groupment of a lot of companies to help developers write and design their APIs in a cool way. We will discover how just a bit later. And, sorry, Pistahx is based on many modules which interact together to generate your API from your design. So we will see how. And here you see that there are some modules, for example, Pistahx spec, which will help you generate Haxe type defs from your specification. It can also automatically scaffold all the boilerplates for your routes and also generate type-safe mappers between your schema, your DB, and your API, what object you want to spread out to the world. And we also offer some Docker containers within the modules of Pistahx, so you can deploy, run, but also build your API, leaving your local environment completely clean. So now let's see some details. Here is a view of, it's a partial view of Pistahx ecosystem for now. So it's of course based on Haxe. It targets the Node.js environment, implements OpenAPI specification, uses Redis as a fast cache store. Sequelize, I don't know if some people know it yet. It's an ORM. It's a DB interface, multi-DB. So it can connect to MS SQL, for example, if your DB is on Microsoft server, or SQLite if you develop a small application, or any other DB. You also see that Pistahx implements Moustache. This is the little Moustache logo, which is a templating engine. And here you have the ELK stack, which is greatly renowned nowadays. And some other parts are Passport, which comes from the Node.js environment, which will help you handle all authentication on security around your API. And you also see that we have Docker in it. So, as I said, to help you get your app in containers and deploy it everywhere. So, let's see how to start fresh and bootstrap a new API using Pistahx app, which is a demo application hosted on GitHub. So everybody can easily try the project in minutes. So I will try to demonstrate that it's not so long. So here I have my command line. Sorry. I will just clone the repository of Pistahx app. It's done. Now you have a little command that will install, for example, gulp, which is a task runner. So this prepare sh will install some stuff before we can actually build the project. We'll just wait some time. And after this, you see that there is a gulp command, which will provide a little menu on which you can select what you want to do with later. Okay. Okay, so now the solution is prepared. I will type gulp. Sorry. Here you can see the menu. So you have a run task. The run task can be run before you build your app. So I will first build the app. So this part will be a bit long because it has to get all the dependencies of the project. For example, all the node modules used in the application. So this is what happens here, the part we can see here. And after this, there are a lot of things that happen for building your application, but you control what happens because the gulp file is included in Pistahx app. So you can, for example, here you can see that we pull a companion website. The idea is, for example, to keep your website. Of course, it needs to be a single page website, so it doesn't require some other backend technology. But if it's a single page web site, you can imagine to pull it with your API and deploy it in the same containers, for example. But also you can deactivate this part in your gulp file, so it doesn't happen. And some other things are happening. I'm not detailing it now. You see here that I'm using Haxe JSKit from Clemos, which I forked because I just had to fix something, and I'll make the PR soon. And now the app has been pre-built. We can just gulp run. So there are many things that happens also here. I will explain later. And now the app is built and running on port 3000. So let's just try. So this is not really your API. This is an automatic documentation that has been generated by your specification. But what we can see here is that there are some routes that have been published. And this documentation is interactive, so you can try out your routes. This is the get employees, for example, route. And you see that the documentation is interactive because you have a try it out button, which will call really your deployed API, the API that's running on the host. and render the result on the response body. So this is a very cool way to test your application. Even before that the logic, the business logic is written, you can get this documentation and provide it to your customers, for example. So now back to the project. Let's just have a look at the project structure after cloning the demo application Pistahx app. So let's go on GitHub. Okay, there are a lot of files on the root folder, but it's only to help you deploying and developing your project. You have, for example, the gulp file that I mentioned earlier. But besides this, you only have an app folder, and when we go in the app folder, you will see it's really compact. You have a YAML file. This is the specification of your API. I will show you what's in it. After this, you have your configurations. You can see that the configuration is also YAML based. YAML is a language, we will see. And each environment you target will be, each environment that you target will be configured in a file like this. This is the my local configuration in local YAML file. And besides this, you have a business, folder where you will have your Haxe code containing your business logic. So, yeah. This demo app you saw, if we open the package.json file, you will see that the app depends on Pistahx and Pistahx modules. I show you this because I need to tell you that Pistahx is and will stay a dependency of your project. It's an open source project, but your app is independent of it, and it just use it as a dependency in your project. So this is why the application itself is really, really compact and will stay compact. All your business code will stay here, and there is no link between the technology and your app. Of course, the technology will run your app, but there is no leaks. So here is a view of the development workflow with Pistahx. There are three parts. First, you will configure your API environment. As I showed you, it's on the app.conf and the name of the environment.yaml files. Then you will design your API. We will see just after what's the meaning of designing an API. It's just specifying how your API will answer some hits and how it will respond. And the third step is to implement your business code. And of course, it's done in the Haxe language. Sorry. So I told you Pistahx implements the Open API specification, which was formerly called Swagger. It's a strong and renowned specification for REST API standardizations, and there are many, many tools available on the net to use this technology. For example, you have a neat editor, online editor called Swagger Editor. You have plenty of samples on this website, so you can have a look on how it works. But basically, this editor, editor.swagger.io, is just a two-part screen. On the left-hand side, you have your specification of API. So, for example, here we can see that this API provides a get pets route, which we can find just here. This is a link between the two. It's automatically synced. And we can see that the get pets route is here. And all the information about the routes are rendered in a UI fashion way. But the information is also here, present here. For example, the description of this route and all the parameters and the response format are described in this specific language, which is YAML. And this is the starting point of designing your API. It will consist of writing some YAML code, as we see here. And the resulting will be a nice documentation, interactive documentation, as you see here. So I show you editor.swagger.io, which is a small editor you can use for your work. And the Swagger UI is actually what you can see just here. And you notice that I embedded the interactive documentation while deploying my application. So what you see here is the port 3000 serves my documentation, but also, of course, can serve, API.v1.employees. It also can respond to direct hits. So this is the Swagger UI. Now back to Pistahx. Here is a sample of a local configuration file. It's a simple key value file on which you can define some keys. For example, I don't know the environment name. Okay, it's not very interesting, but the Redis. I told you that Redis is an important part of the technology. I choose Redis because it's ultra fast and ultra neat, but maybe later we will integrate some other cache store, I don't know. For now it's Redis, it's fixed to Redis. And what we can see just down there, it's some deactivated keys. So the idea behind this is to be able to activate or deactivate some functionalities for your application by just commenting or decommenting some keys in the configuration file. So now let's have a look at the specification itself, which I say it again is the starting point of your development. What we are looking here is just a part of the API.yaml file, which will be able to provide interactive doc and so on. So what we see here is that in the YAML file, we can not only define some routes, but we can also define some models. It's meaning that the documentation, for example, but also your code, will know which type of objects it can render to the outside world. So here is an employee model defined in the specification of my API, which have some fields, for example, ID field, last name field, first name field, and you see that we can define some types for these fields. Okay, nothing fancy. Another definition is the employees definition, which is simply an array of employees, And here we can see that we define a route, get employees, that is bind to a definition which is employees. So this means the get employees route will render objects of type employees. And what I didn't show you is this special key called operation ID. So the whole idea of Pistahx is to being able to design your API and bootstrap automatically all your boilerplate code. So what I call boilerplate code in this type of situation is, for example, the routes. What you can see here is a get I made a mistake. We will see just later how Pistahx bootstrap all the routes, but here is a business code, a part of my business code. I just want to show you that this get employees route will call later, we will see how, this method, this Haxe method. And what's interesting here is, this part of the code is from sequelize the ORM to the database, so you can know that you can see that we call a find all method on a model with a limit of 5, and then we do something with the result. Okay. But the interesting part is the typing part, we can see that this method will respond a promise of array of employee. And we can also see just after that there is a DB employee model which is here, and I render it in red because these two parts have been auto-generated by your specification. So let's see how. There is a model in Pistahx which is called Pistahx spec. So it's a Haxe project used to generate Haxe code from your API YAML file. So here is a sample of how you call it. You have many types of use with this little tool. So for example, if you input the type roots and input your YAML file and output to a specific Haxe file, it will generate it. And this file will contain all express style, because I'm in Node.js, express style roots definitions as this one. This has been auto-generated by Pistahx spec, so we can see that this is express syntax in Haxe. So you see that your API will answer to get hits on this employee's root, and that it will call the get employees method that we just saw before. Again, this file has been auto-generated. You only have to write your specification and your business logic after this. Here is another example of what you can do with Pistahx spec by using the type equal typedef input. It will generate this time a td.hx file, which can contain more than one thing. Actually, it will contain model typedefs from your spec. That's what we saw just before. For example, this. This has been designed in your spec, and the tool we saw will automatically generate Haxe typedefs from this specification. And a thing we will see just later is also you can auto-generate some mappers between your API models and your DB models. And it's all defined in the spec. We will see how just after. Here is an example related to what I showed you in the YAML file, where we defined two models, the employees model, which is an array of employee, and the employee model. So this file, again, has been auto-generated by Pistahx spec based on your spec, and we have two type defs, simple, a list of employee and the employee type def. Okay, so now for mappers. When you have a new project, sometimes you work with legacy DB, and it's sometimes very, very hard to get your data somewhere else, so you have to stay with the legacy DB, which is sometimes badly designed, bad names, the fields are not what you want them to be. So in the api.yaml file, on the models, on the definition of the models part, you can use some keys, which I rendered in red, that will help you bind your API models to your DB models. So what you can see here is a xdto model key, which refers to the name of the table in your database. It could be anything else, It could be anything else than employee. It's just a name of the table you will target in your DB. So for example, the xdto model name could be different than the employee in green model. And the same applies to fields. For example, your API will serve an ID for employee, but your old DB doesn't have this field called this way. It's called employee ID. So here is a very, very simple example on which you can see that you can map easily two field names that doesn't match. And here is the result, again auto-generated by Pistahx spec. So it's a mapper which implements a method which will map from your DB model to your API model. You can see that it gets a DB employee type, again auto-generated, we will see later, from your DB. And it renders an employee type. And here you can have a view of the mapping I told you with two fields with different names. The last part is when you're working with a DB, is you might want to auto-generate Haxe definitions for these DB models. So there is a third part with the use of a model called Pistahx DB. This tool is a work in progress. Actually, it's a work. I'm trying to refactor it because it's still actually a JS tool for now. And I would like to rewrite it to Haxe. It will be better. But for now, it can still do some stuff. It can render some, it can auto-generate some HX files from your DB, which will contain, for example, this, which is a representation of your DB in Haxe language. So this is the model we saw earlier, and you can see all the fields from the DB. So now I presented Pistahx core and modules. We are back to Gulp. So I told you there are many possibilities with Gulp. Here I present some of the simple commands I added to the project. You have a build command, which will install all dependencies needed to build the project. Maybe build is not the, Gulp build is maybe not the best name, but I may refactor it later. But it installs all the dependencies needed to build the project. And then you have a Gulp run task that will transpile your spec and business code to the target language we are aiming. And the Gulp pack is pretty much like the Gulp run task, only it will not start your API after this. So you can see here that the API is running. If ever I use the pack method, it will do the same, but not launch the API afterwards. So, I told you that Pistahx pack will do the same as Pistahx run, meaning that when you did this, your API is ready to be run and to be deployed. Actually, the result of the transpilation is provided in a distrib out folder, and this folder can be taken, given to somebody else, deployed, or whatever. It should run, because it contains everything needed to run on a Node.js stack. So for example, here I'm using a little sample to show you. Maybe some of you know the Elastic Beanstalk technology. It's a deployment stack on Amazon AWS. And you can see here with 3 lines that we can easily deploy our transpiled application to this cloud with these 3 commands. And of course, you have to set some keys, for example, environment variables on the cloud, so your application still knows which config file it should use. And here is another example of the deployment part. We provide a little container. It's really small because it's based on Alpine Linux. Maybe some of you know it. It's a small distribution of Linux. So it helps you spread your app easily on any cloud, any Docker-ready cloud. And Docker technology is a it's a very cool technology that I invite you to discover if you don't know it yet, because it covers all the predictability, deployability, and scalability issues. So this is why I use it now. Okay, here is a small feature among others in Pistahx. I told you that Pistahx is heavily based on cache to give you the power of having a true fast API. So by implementing cache, you have some issues to think about. And one of these problematics is cache invalidation. The meaning is that you can cache your data a long time, but you need to think about when the cache will be invalidated, and especially when there are some updates on the DB, the cache needs to be flushed for the other people to get the refreshed data. So what I propose here is a simple way to do this within the YAML file. So here is an extract of here is an extract of the YAML file on the put route for an employee. This route will update an employee. Okay. So you can define a key on the YAML file, which is called xCacheFlush, which will automatically flush the cache for other routes when a route is called. So this means when modifying an employee using the put method on your API, the employee's get route the cache will be flushed. So this is really helpful. And of course, what you can see is that it's an array, so I can define other routes. It's still work in progress, but it's a big part of the technology. Okay. Sorry, how many time I got?
5 minutes.
5 minutes, okay. So let's try to do a really quick sample. The bootstrap of the API is done. I already did it, so it should be fast. I just commented some parts of my code, so I will decomment now, and we will see the result. So let's just run the API again. Of course, when you are in development mode, you will not be in the command line. You will be in the, for example, Sublime. Okay, and you have possibility to build your app with Command B, for example, if you are on Mac, and you get all the, for example, all the code completion on the here, for example, employee. Go to definition. We are back in the auto-generated file with your models, and so on. Okay. So what I commented in the API are two new routes, which you can see here. It's a little small, sorry. It's an albums route and album. I use a small local DB, SQLite-DB, which contains some albums, artists, and so data. So I'm using it for demo purpose. So first of all, I will pretend that I want to open two new routes on my API. And I spoke to my mobile team, and okay, we have agreed about a format of parameters and so and response. So we decided to open these two routes, one of which is called get albums, which will get all the albums of the DB, and the other one is get an album, one album, providing one album ID. The second part is to decomment to write, the definition of what's an album and what's an albums. So this is down on the definition part of the API specification. I will uncomment this part. Again, albums is only an array of album. An album have some fields which are binded in this case to a DB model with the XDTO model key. And we can see another example of mapping between the DB field, album ID, and the ID, the field I want outside, ID. Okay, so saving this file, back to the business class. This is where you will actually implement your code. So let's uncomment some code. Some parts are, I'm not so proud of some parts. There are still some untyped code some places. So of course I will not I will not stay in this position. I will try to kill all the untypes and then dynamics in the code. But for now it's still in progress. And when you define your routes, you of course have to write some business code. So here we see two new methods that I just wrote. I was really fast. The get albums route, which will provide at the end a promise of array of album. And the get album that will provide a promise of album. Okay? And the syntax is pretty small in it. It uses sequelize syntax. So we are only finding all the albums on the limit of 5, and we include the artist model. I will show you how. It's an example of association. You can associate, of course, in any ORM, you can associate your tables. So I'll do the same here to provide the artist name for each album. It's a simple test. And the same for one album. The only difference is that we provide a parameter, which is the album ID, to get the album. So now that I have uncommented all the code, I think, if I'm not wrong, yeah, you saw that I just touched two files, the API.yam file and the business class. Okay, we did this. Define the album and artist definitions and routes. We did this. Okay, we did this too in the business file. And we also did this. So now let's gulp run and see the result. API running again. So at first we only had this employee pack of routes, which had 3 routes. And if I start again, I see the new album category, which have 2 routes, which we defined earlier. And as I told you, it's an interactive doc, so you can right away try your API and see the result here. So this is an array of album with an artist name for each album, representing the association of 2 models within the demo. And for example, let's pick one, this ID 5, and I will try the get album with an album ID of 5, just to see if it's working. Yeah, working. So what you saw here is a small round trip around what you can do with Pistahx by defining some specification for your API and writing some code around it. Sorry, I lost my... Where is that? Where is my presentation? Sorry. Just lost it. Here is it. Ta-da! As you saw, the doc now showed 2 new routes. That's what I said. So what's next? Pistahx is still version 0 dot something. So I'm trying to think now on a roadmap to V1. So ideas behind this V1 would be to generate type defs and code for the complete open API spec. For now, it's not the case. I would like to implement a parser for the API.yaml file we just saw. This type of parsers exist in the TypeScript world for now. So I'm really interested in implementing it in a Haxe language. Also, I still have to refactor some modules. So they will be Haxe modules. For now, some of them are just JS modules. Another idea would be to implement other targets for the project. For example, I don't know, Lua or anything else. As I told you, I would like to get rid of all the remaining untyped and dynamic in the code. I'm pretty new to the Haxe language and community, so I'm still learning. And other ideas, for example, generating all the CRUD roots. For example, what you saw on the demo, was that I still have to write the specification on the business logic for example, employees. But maybe in some case, it's pretty obvious what you need to do. So maybe I will try to add an automatic CRUD generation from something. Another idea would be to generate the API.yaml file, but I'm not sure about from where and from which data. That's an open question. And another idea, but I'm not going to talk much about it now because it's really, really early work in progress, but it's a big idea for me. It's a legacy API booster, which would help you to put a proxy behind, above old and slow legacy APIs you own. And with this proxy, which will be Pistahx based, you would be able to improve the performance of the underlying API by defining good caching strategies. Maybe I will talk about it another day. Thank you, everyone, and welcome all the newcomers on the project. And if you have some questions now, I'm ready to answer.
Hello.
No questions. Everything was clear, or maybe everything was unclear? I don't know.
When you generate the code, if you modify it, you have something to update it, or it's just right?
If you gulp run again, it will transpile again.
Will overwrite the.
Yeah. It will overwrite all auto-generated code and leave your business code clean.
Okay.
Yeah. This is a really good question, because when I first encountered the Swagger technology, I was really dubitative about how they act. Because, for example, if you go on the Swagger editor that I showed you, you see that you can generate a server here. So this is pretty much what I started to do. But I didn't generate a Node.js server, but I implemented the Haxe target for the same reason. Maybe someday I will propose my technology to this team, so they have a Haxe target here. But actually, they are not working the same way I do. They use a Java tool, which is pretty heavy to do this. So I split my technology from this kind of processing. And to answer your question, when you generate this server, it will generate it from the API, but it's not easy to code some business code in it and generate it again after. So this is an important part of Pistahx, that you can generate and generate again without losing all your business code, of course. You don't lose anything.
I was just going to mention you had one of the things you wanted to do was to generate type defs directly from the open API spec.
Yep.
And I think the way to do that would be definitely like with a macro or something.
Should be, yeah.
To get you started, there's you want to look into. I know that there's a way to generate type defs from JSON payloads, and it looks like just looking real quickly through the open API payloads.
Nice.
There's examples that it will give back. And
That's nice.
So you can use those to basically, there's 2 or 3 examples that have been put up on GIST. So
Thanks.
try to dig those up, and then maybe those will be useful.
Will do. Yeah, thank you very much. Just a little word about JSON. I presented you my API spec in the YAML format, but YAML and JSON are completely compatible. So yeah, it's a good idea. Thanks.
Thanks. Maybe it's a silly suggestion, but did you think about macro to generate the code so you don't have to run gulp? Because I'm not very fond of gulp. If you just regenerate all the API on compilation time, I don't know if it's possible. I don't know if you're thinking about it.
Actually,
what do you think about it?
Yeah, actually, I'm still a bit new to the technology, as I said. So, for example, the workshop yesterday on the macros was pretty interesting for me because I learned a lot of things, and I still not discovered all the pieces of Haxe language and technology. So, of course, macro will be one of my concerns in the future. Thank you, then.
For contributors.
Pardon?
You're looking for contributors.
Yeah. Everybody is welcome on the project. You have the GitHub project. Okay, thank you. Thank you all. Thanks.
This one is good? Yeah. Okay, sure.